This meeting.
Okay. In yesterday class, we discussed about, in EAGRP lab, we have seen forming EAGRP neighbors connecting two buildings with the EAGRP neighborship. In today's class, we will see the, and also we discussed about NATs, right? We discussed about static NAT, we discussed about dynamic NAT, and also we discussed about PAT, port address translation. And today we will start doing the labs of the NAT. Before we do that, any questions from the previous class, guys? Okay, all right. We'll start the labs. Let me start the packet tracer. So, well, before we start the packet tracer, let's start talking about the NAT, right? So, static NAT, just to do a recap, it's one-to-one mapping, right? So what we'll do in our lab, we will take a router. We will take a router. And then we will put an inside IP. Like, for example, this is like an inside interface. And then we will take another interface, which is outside interface. Okay, this is called as outside interface. So we'll connect a computer here or PC. And then we will connect a server here. So here, so we have to use a 10.ip, which is the private IP. Let's pick something like 10.0.0.2. And then let's pick a server IP, which is like 39.39.39. Okay, something like that. Okay, so whatever the translation that we should do, like let's pick the interface, the 10.0.0.2 should be translated to a public IP. Let's pick this public IP as 39.39.39.39.1. Okay, so now the 10.0.0.2 should be translated to 39.39.39.1 interface, and then should be able to reach out to the destination, which is 39.39.39.39. Okay, that is how it should be. So now let's do the translation. So translation should be happening from 10.0.0.2 to 39.39.39.1. This is the static translation, one-to-one mapping. Okay, let's do the lab for this one. Any questions on the theory part? I'm hearing some kind of loop. I don't know what it is. Is that a question?
No, sir, no.
Okay, all right. I'm going to start the lab then. So I'm going to take a PC. Just going to take something like a router. Let's pick 2911. I'm gonna pick a server. So as per what we thought, the IP address here should be 10.0.0.2. And the IP address of destination will be 39.39.39.39. So there should be a link between this one to this one. And then there should be a link between here to here. Okay, so the internal IP of this interface. So I'm going to pick this interface as 10.0.0.1, obviously. The interface IP, and I'm going to pick this interface IP as 39.39.39.1. So NAT should be translated, static NAT. NAT should be translated like 10.0.0.2 should be translated to 39.39.39.1. So that is the NAT transition that should occur here. So for your understanding, this is called a private IP. Private IP or internal. And then this is called the public facing or external. Public or external. Okay. The labeling is done. Now let's start doing the configuration. Okay. So very basic. We're going to do the configuration of this one. IP address 10.0.0.2, 55.2, 55.2, 55.0. The router. Oh, let's go ahead and configure the gateway. 10.0.0.1. And then go to the router. CLI, no. Enable. Let's check this interface. Just as 0. Just as 0. No shit. IP address 10.0.0.1, 255.255.255.0. And okay, so this piece is done. Now let's go ahead and configure this one. /1. /1. IP address as 39.39.39.39.1, 55.255.255.0. No shit. Let's go ahead into the server. Config interface is a 0. Let's define the IP address 39.39.39.39 to 55.255.255.0. Go ahead and then define the gateway 39.39.39.1. Okay, let's go ahead here and then check the routing table. Show IP route. 10 network is connected, 13 network is connected, both are connected routes. So let's go ahead here, then go to desktop. Ping 39.39.39.1. So from PC I'm pinging this interface gateway. Let's go ahead and check 39.39.39.39. Now, so now I was able to go to the router.
Sir, can you please allow Bhavna? She's rejoining.
Sorry, what? I didn't get. Is that a question? Okay. So 10 network is trying to reach out to the 9 network. Now let's check the NAT is happening or not. Show IP NAT translations. The NAT is not happening because we did not configure the NAT, but there is connectivity between them. So now this 10.0.0.2 should be translated to 39.9, 39.39.39.1. So we have to configure that. So to configure that, config terminal, IP NAT inside source, static NAT, this is static NAT, and then the inside IP is 10.0.0.2, and the outside IP is 39.39.39.1. Okay, and we have to specify what is inside IP and what is outside IP, right? So inside interface gig 0/0. So this interface should be inside internal. So I'm going to do that one as internal. IP NAT inside. I have to define this as the external. Okay. Interface gig 0/1. IP NAT outside. Okay, so we created a NAT, the translation from 10.0.0 to 13.13.13.1 with what we wanted as a translation, and then we decided this as the inside and this as the outside. So now let's go ahead and generate the ping. Now let's go ahead and check the NAT translation now. Okay, show IP NAT translations. You observe now. So inside local is 10.0.0.2. It's trying to go to 13.13.13.1. Outside local is 13.13.13. Because this is translated to 13.13.13.1. Outside 13. This is the destination. It does not change. So what we are translating is inside local is translated to inside global. So 10.0.0.2 is translated to 13.13.13.1, like we mentioned here. But the destination stays same. 13.13.13.13 is inside outside local is same as the outside global. So that is how the NAT translation happening between them. And this is the port information. As I told you, it will pick a random port for the source information. It can be, because it's ICMP, it's using a random port. It's going to destination port. It's mapping the same source port and the same destination port, because it's an ICMP. But when you start using an application, then you will see higher range of ports, like a web application or something like that. But here we are just doing a simple ping test. So what we do, let's generate some more traffic. So 10.0.0.2 is the source PC. It's trying to go to 13.13.13.39. It's translated to 13.13.13.1. It's going to outside local at 13.13.13.39. That is the outside loop. Okay. Any questions, guys? No questions, guys?
No, sir.
Okay, cool. And then the concept is clear. So now I'm gonna wipe off the configuration. I wanted to make sure everything is clear. Now let's talk about the dynamic NAT now. So I'm gonna remove these devices. Delete. Okay, so now let's talk about dynamic NAT. Share whiteboard. So same example, we are not doing the one-to-one mapping. So what we can do is we will use the whole subnet as a source. So let's say let's pick something like this. So the inside interface stays the same, outside interface stays the same. There is no big change, but we wanted to make sure we we create a NAT pool. So let's say we create a NAT pool. For example, the NAT pool is 39.39.39.1 and 39.39. Let's say 3. Okay, so this is the pool that we used. It can do one this IP or this IP. We created 2 IPs. So this PC, let's say you have one more PC. Let's pick 2 or 3 PCs. Okay, so let's pick a switch here. I'm gonna erase this one. You take a switch. And you pick one more PC here. Let's say this is 10.0.0.3. And then you pick one more PC here. Which is 10.0.0.4. So this is connected to switch, this is connected to the switch, this is connected to the switch, this is connected to the inside. So whichever PC comes from, like whether it can be 10.0.0.4, 10.0.0.3, 10.0.0.2, any PC coming from the inside interface, if it hits the router, so it can be this PC, it can be this PC, it can be this PC. If it hits the inside interface, it should be translated to either this IP or this IP from the pool. So that is the dynamic, right? Dynamic means like we create pool of NATs and we can use one NAT of this one or this one from the pool. It can be any PC. So now let's build a lab so that the translation will be happening to this one and still this is inside, this is outside. Okay, so any questions, guys?
No, sir.
Okay, cool. So the lab is clear. Let's
If we wanted to clear any static NAT, we can clear them if we want.
we can clear them, but I don't want any confusion to happen. I can do it much faster by clearing stuff, but I have seen people getting confused if I do the same, like removing config until putting it back. I have seen people getting confused.
Okay.
I can put some no commands and then remove the stuff easily. That will make my life easy, but your life complicated. Okay, so I'm gonna take 3 pieces. I'm gonna take the switch. I'm gonna take a router. Let's do some connections. Let's pick a server and then do the same thing. Let's pick a connection. So again, 10.0.0. Let's pick 2, 10.0.0.3, 10.0.0.4. Okay, so let's pick all of them are in VLAN 10. So we will create a trunk port, allow that. Okay, so here this IP, this should be gig 10.0.0.1. This IP, this side 39.39.39.1, and this IP is 39.39.39.39. So the translation should be pool, source pool 10.0.0.0/24, meaning it can be any PC, inside network. Inside and the outside. And the outside. NAT pool. Let's pick 39.39.39.1 to 39.39.39.3. Okay, it can be any transferred IP. So we can call this inside network, inside or private, and then this is outside. Okay, click save. Just in case I don't want to lose it. Again, let's go ahead and quickly define the interface IP addresses. 10.0.0.2, 55.255.255.0, default gateway is 10.0.0.1. So this configuration is done. Let's go to switch and then define the VLAN. And then study VLAN. These three ports 01, 02, 03, interface range FA0/1, FA0/3, switch port mode access, switch port access VLAN 10. Short. Okay, this port should be a trunk port FA0/4. 0/4 switch port mode. Trunk switch port trunk allowed VLAN 10. This part is done. Let's go to router. Let's create. Let's see what interface it is. Interface is 0/0/0. Not shut. Interface is 0/0/0.10. Encapsulation .1Q10. IP address 10.0.0.1, which is the gateway to 55.255.0. And okay. Now let's see if we can ping the gateway or not. Ping 10.0.0.1. This interface just came back up. Okay, it's pinging now. Okay, so this part is done. Now let's go ahead and define this part. On field interface gig 0/0/1. IP address 39.39.39.1. 255.255.255.0. Now shut. Let's go ahead and define the IP address here. Config. .39.39.39. 255.255.0. And what settings define 39.39.39.1. Okay, let's go ahead and ping 39. The destination ping 39.39.39.39. Okay, first one failed because of the broadcast, and then it all worked from there. Now it should be pinging all the packets. So now let's go here and check show IP NAT translations. No translations, but we have to define this as the inside interface. This as the outside interface. Let's do that. Interface gig 0/0/0 IP NAT inside interface gig 0/0/1 IP NAT outside. Okay, so NAT part is done between the translations. Now define the interface with any of the IP in the pool. So we have to create a pool IP. So for that, I'm going to create access list, define the number. I'm going to put number 10, permit 10.0.0.0, any IP in that subnet 255. I have to define the wildcard mask 0.0.0.255. That is the pool that I created for the any PC inside. For this source pool, I created that. And then I'm going to define the outside NAT pool, which is IP NAT pool, and then define the pool name. I can say study Jan18 pool. That's the name of my pool. It can be any name. I can define 39.39.39.1. The range should be 39.39.39.3. And I have to define the net mask, which is 255.255.255.0. Okay, so and then let's define the IP NAT inside, and then define the source, which should be list, which should be 10, whichever number we created here, that should be the source list, and the destination should be pool, and then define the pool name, study underscore Jan 18 pool. Okay, so I created IP NAT source inside. The source should be this list, which is any of this IP, and the destination will be pool, this one, this pool. Okay, so now any of this IP will be transferred to this pool. So now let's go ahead and generate some pings, and then check the NAT translation here. Show IP NAT translations. Did I did the inside correct, outside correct? Did I put the NAT? Let me check. Let me clear some up. Let's ping. Okay, let me check the NAT again. IP NAT pool inside. I define the pool. It should be that one. Define the net mask. That is correct. Let's see the NAT interface are applied or not. Oh, okay. I did the inside of this one, but it should be inside of this because the packet is coming from this interface. So it should not be this interface. So I have to remove it from here. So hold on. Oops. 1 second. So the mistake I did was I am doing the IP address gateway of this interface, but I applied the NAT inside of this interface. So I should be applying the NAT on this interface. So bear with me 1 second. We'll fix that and then we'll check. Okay. Now, conf interface gig 0/0/0, no IP NAT inside exit interface gig /0/0.10 and then IP NAT inside. Okay, now let's see. Go ahead here, R-delete. Ping it. Let's check here. Show IP NAT translations. Okay, so 10.0.0.2 is translated to 39.39.39.1. Okay, now let's go ahead here. Ping some traffic. Ping 39.39.39.39. Pinging. So 10.10.3 is transferred to 39.39.39.2. Another one in the pool. Now let's go ahead and here. Then ping. 39.39.39.39. Now let's go ahead and check. See, if you observe, 10.2 is translated to 39.39.39.1, one from the pool. .3 is translated to 39.39.39.2. 10.0.0.4 is translated to 13.13.13.3. So it's using, this one is using .1, this one is using .2, this one is using .3. It's getting translated accordingly from the pool. So here we are dynamically mapping one private IP to one public IP in the pool. Any questions?
Like it is taking like accordingly, right? If we run the third PC in the second, so it will take like 39.39.39.2, right? For 10.0.
It's random. It's randomly picking it. After 10 minutes, it will pick it random one. There is no order for that.
Yeah, okay.
There is no specific order for that now.
Sorry, it's a dynamic, right?
It is a dynamic.
Yeah, okay. There are the two types or one type?
I'm sorry?
Only dynamic only we use?
Static we already did, right?
Yeah, okay, fine.
Static is done. We did dynamic now. And after this one, we will put multiple IPs, multiple devices, but only one IP. Because we'll remove the pool now. We will put only one IP. Okay. And then that is a PAT.
What is this called, sir? PAT?
Yeah, port address translation.
Yeah, okay.
Okay, so now let's go back to the whiteboard. Guys, is it making sense? Any questions, guys?
No, sir.
Not making sense? Okay, so now, I have again 10.0.0.0. This is 3. Okay, .3, .2, .4. Here, instead of putting, we did what? 1-to-1, which is static. We did many, or we will say many or group to a pool, that is called dynamic. And then we will do many to one, which is called PAT. Okay, so here we have many PCs, but we will use only one IP to translate all of them into .1. But to do that will be mapped to using the source port, right? Every IP will have a different source port mapping. That is also called, as we talked about that, it is also called as NAT overload. Okay, just it's called PAT, port address translation, or NAT overload, just a different name. Okay, so I'm gonna go ahead here. Any questions with this setup, guys? Again, many internal IPs mapping to one public IP, 39.39.39.1, inside interface, outside interface, the same server. Okay, no change. Okay, same setup, guys, but instead of having a pool of outside, we are just taking one IP. Okay, so let's go ahead and finish that. So now I'm going to remove the pool. Okay, so on the router, I'm going to remove the pool. So let's check, show, run what we did for the pool. So we did a pool like this. I'm going to remove the pool. No IP. No IP NAT source. IP NAT inside source. And then we define the list 10. And then we define the pool. Study underscore Jan18 pool. We
Sir,
remove that.
you need to share the screen.
Oh, I'm
You are
not sharing.
not sharing your screen, sir.
What am I sharing? Still whiteboard?
Yeah.
Okay, sorry. Okay. Okay, so what I did earlier, we had a NAT pool configured, IP NAT pool, this one. So now, and I applied that pool to the NAT section, right? So I removed that section. Now I'm going to remove the actual pool as well. No IP NAT, and then I defined pool, pool study underscore Jan18. I removed the NAT pool as well. Okay. So now I have to do just one interface, right? So that interface is geek 0/0/1. So to do that, IP NAT inside source list. The list is 10. That is not changing. The inside IPs are not changing. And then do interface gig 0/0/1 overload. That is what we have to do. That's it. So now whatever the inside IPs are coming from this range with the 10 range, and the 10 range, you guys know 10 range is nothing but 10.0.0.0/24. That is the 10 range that is mapped to the outside interface with the overload. And the outside interface is called as external, and the inside is the internal interface that we already configured, which is, if you see show run, this is the inside interface and this is the outside interface. Now let's go ahead here, clear the arc. Here, let's go ahead and clear the arc. Let's go ahead and clear the arc. Okay, let's go ahead and generate the pings. Pinging, pinging, pinging. Now let's go ahead and router and then do show IP NAT. If you observe, .4, .2, .3, everything is transferred to 39.1. Everything is transferred to 1. Only 1, 1, 1, 1. Everything is transferred to 1. But earlier, if you observe, 4 is transferred to 3, 3 is transferred to 2, like that. But now, everything is only one interface. So, but if you observe, it is picking this 4 is picking the 1.1024 random source port. 6 is picking 1025 random source port. 29 is picking 29 port. So there will be a random source port that will be used to go to the destination. But it is only using one public IP. That is called PAT, which is many to one. So you have many internal IPs, but we are using only one public IP, which is the outside IP, which we call it as the PAT, port address translation. Okay. Any questions, guys?
So for large organization, which NAT will be mostly used?
For a larger organization, they will not put the NAT on the router itself first place. They will put the NAT on the firewall. They will have a lot of NATs. They will buy a lot of NATs, and they will do the firewall policy to translate it. They will not use the router to translate. There are a lot of reasons for it. But at a CCNA level, if you ask me a question for a CCNA level, I would say PAT is the most used NAT.
Okay, sir. Thank you.
So, sir, for the inside global, after the IP address, it says 1024, 1025 and everything, right? You in the last class, you have said that there are some reserved ports for source port and destination port. So, the first four are the source port and and the remaining are the destination, or how it works in the inside global?
Yeah, as I told you, the source ports when you're doing the application, okay, when you're doing a TCP application or like that, 1024 to the 65535 is the random source ports. But here we are using ping. Ping is an ICMP, it's not a TCP or it's not a UDP. So the example I told you is for the real time, like doing a web browser traffic or real time voice, making a WhatsApp call. Those kind of traffic will be using the random source ports. But here you're just running the ICMP. So you will see all kind of random ports.
Okay, yeah, got it.
Okay. Okay, I want to stop there with the NAT. I wanted to move to the NTP. I'm running out of time. Any questions, guys, before I move? Okay, all right. So stop share. Whiteboard. NTP is network.
Sir,
Yes.
sir, I have a question. Sir,
Okay.
if instead of just one server, if we have multiple servers connected to the router, then we will have to configure multiple NAT, like we have to configure NAT for like multiple times, no?
We don't have to. We can put all of the servers in one pool, right?
Like if router is connected to one server, that will be one IP range, right? One network, I mean. And if we have another server on another network connected with the router, and if you want to do NAT for that,
We can still use
how?
for multiple subnets.
Mhm.
We can still use one NAT, but you're right. You need to put multiple NAT statements.
Yes. So we'll define multiple ranges for that, right?
Yes, you can. You can define multiple ranges. Depends on your use cases. Yes, but you can use a single NAT IP.
Single NAT. Yes. Thank you.
Okay. All right. Network time protocol. So network time protocol is an application that is used for the time synchronization between all the hosts in the network. Let's say you have multiple hosts, meaning like this PC, another PC, another PC. There are like 10, 15 PCs in the network. And you wanted to run the time commonly on all the PCs. The reason why is if you're sending a request, like if you want to do a file transfer, let's say you have a switch here, and you wanted to do like a file transfer between these PCs. When this PC is sending the request, this PC should respond back with the same time frame. Otherwise, the PC will think that the response came from a different time frame and it will get timeout, right? So every application will have a certain timeout. It waits. Time period it waits. If there is no response in that specific time period, it will fail and the connection will not happen. That's why we wanted all the devices in the company should be on the same time. Just like think about like you are in a specific location. Let's say you're in Central Time Zone. You had a flight. You went to let's say New York in a Eastern Time Zone. Okay, so now your phone or your laptop will be automatically adjusted to the Eastern Time Zone if you select the location specific time, right? Your location, based on your location, your time will be adjusted to automatically that time zone. Similarly, in your network, all of your PCs will be should be in the same time zone. Otherwise, there will be problem with the communication between the devices. Okay, and this synchronization will be done by a protocol called NTP, Network Time Protocol. And how does this really work? So there is a concept called stratum. So let's talk about this stratum. So if you pick the globe, there are like atomic clocks everywhere throughout the globe. for US region, UK region. That's why you will see UTC, EST, CT, PST, MST, IST. There are different standard times for every country. There are different standard times, but every region will have the atomic clocks based on the location. The clock rotates, but the time never changes for anyone. Right? These are the times defined by the humans. So every region will have their own atomic clock, and these clocks are defining the time for the world. These are the geolocation clocks or the atomic clocks, and the stratum value for this one will be the, like this is the like the value that everyone depends on. This is, let's say this is called a source of truth. So the stratum value of the source of truth will be 0, or the reference clock. Stratum value will be 0. So from this reference clock, every country will use their own government clocks from which the data will be pulled. Let's say US government, UK government, Indian government, Chinese government. From these atomic clocks, they pull their times. For example, Google will be having their own clocks. Bigger companies will try to pull the data, and then they try to share the information to all the people, right? So now that information will be shared to the next level of bigger companies, bigger servers that government agencies will pull the time from. That is called stratum value 1. So from there, the stratum value will be 1, because that is the next level of source of truth, not the real stratum value, but it is the next level, stratum value 1. And from there, I hear some baby voice. Can you please guys mute? From there, you will have more reference clocks. I mean, I would say less trusted clock, but still it is used, because let's say your company is having a server, you will use your own NTP server, right? So these are the company's NTP servers. The stratum value of 3. Your company will have is a clock that every device in your company will be using it. So from there, the time will be sent to your companies, and from there you have your PCs, laptops, servers. They all get the data from, right? So this is like they get the data. Data means the time. From where this is the time. So the higher the stratum value, the lower the exact time frame, because this one should send the time to this one, this one should send the time to this one. So there will be a millisecond delay or microsecond delay at least. So people try to make sure the stratum values are lesser, so that they will get more accurate time. Yeah, accuracy. So stratum value 0 has the most accurate clock. From there, the next accurate is stratum value 1, and then the stratum value 0. I mean, then the stratum value 2, and the stratum value 3. Sorry, this should be stratum value 2. This should be stratum value 3. So that is how the stratum works. That is how the NTP works. Now let's see how your company usually gets the time, or a typical client server architecture. Let's look into that. Any questions, guys, on this topic?
No, sir.
Yeah, it's pretty basic or pretty self-explanatory. So let's move on. So you have a host, which is nothing but a PC. The host will be obviously connected to the switch. Switch will be connected to a router, and the router will be connected to internet, basically. And then the internet will have an NTP server, usually, right? So what will happen? The host will send an NTP request. Give me exact time and date, or tell me the time. Give me exact date and the time. The request will be coming. That the NTP request will be sent to the switch, will be sent to the router will be sent to the internet, and then the NTP server will reply back to the host saying that, okay, here is the exact date and time. So all of your devices will be doing the similar action, but instead of going to the internet, you can have your internal NTP server. Okay, you can have your internal NTP server, where your NTP server internally will talk to the external NTP server, and the internal NTP server will be pointing to the host. Here the stratum value, if the stratum value is here 1, that will be sent to the stratum value of 1. It will be 2. It will be sent to the host, which is the stratum value 3. Okay. So this request will be a UDP packet, not a TCP. UDP doesn't need any acknowledgement. It will just ask a request and wait for the response, and it gets the response, and the UDP port is 123. Okay. So this is the concept of NTP. This is how the NTP works in terms of the communication or for the time synchronization. Any questions, guys?
No, sir.
Okay. Let me see. Bharat Reddy Nimma, what is a static NAT? Bhavana, what is a static NAT?
Sir, I'm here.
It is one-to-one connection, sir.
Yeah, one-to-one mapping is called static NAT. Thank you. Bhumika, what is a dynamic NAT?
So in dynamic NAT, we choose from a pool of IP addresses wherein one IP address inside source will be mapped to any of the outside IP address range.
Yeah, we will pick a pool, and inside the pool, we will. It can pick randomly any IP address to do the translation.
Randomly a
It's
lot.
called dynamic NAT.
Yeah,
Okay.
random match.
Diksha, what is PAT, port address translation?
It will have only one IP, public IP address.
Yeah, it
Where-
will have only one public IP, and basically any internal IP will be mapped to that public IP. It will be translated to that public IP, which is also called as overload. Okay. Naveen Kumar, what is NTP and why it is used?
It is used for
MTP stands for Network Time Protocol.
Okay. It stands for Network Time Protocol. Okay. And why it is used?
To exchange a data type.
Shami, why is NTP used?
What name did you call, sir?
Sanayana, why is NTP used?
NTP is used to synchronize the clock, like clock of devices and a computer network chip.
That is correct. Thank you. Shravan, what is NTP port number?
123.
Mhm.
UDP
Dinesh
1.
Reddy, is NTP UDP or TCP?
UDP.
Okay. All right, guys. I'll stop it there. Any questions, guys?
Sir, previous class video.
All right, we'll get it done. Thank you. Any other questions?